Hello there, good afternoon and welcome to the Weather Studio. Yes, we're live, it's 1 p.m. I'm Clare and Aidan, meteorologist here at the Met Office.
And I'm Aidan McGibbon, also a meteorologist. We get together each week at this time to discuss the weather across the UK, around the world, and occasionally we talk about other topics. Now, this week we're covering a very special topic in depth. We're going to be talking about global warming because yesterday, the Intergovernmental Panel on Climate Change published a very important report that warned that we really need to limit global warming to 1.5 degrees in the future to avoid the worst impacts from climate change. And we're going to be discussing in this special Weather Studio Live all the main points from that important report. You can, of course, as always, send us your questions. We're going to have a special guest on, Professor Richard Betts, and he's our climate expert. So please do send us all your questions on climate change, global warming, and we'll try our best to get through as many as we can. But we're also going to be discussing the main points from this special report. First of all, I mentioned the Intergovernmental Panel on Climate Change. Who exactly are they? Well, this is a body that was set up in 1988 by the World Meteorological Organization and by the UN. And essentially, it's a body that gets together and summarizes all the very latest climate science research. And they publish a report every 5 to 7 years. The last main report was in 2013, the fifth assessment report. And the strength of these reports are that they're based on the very latest climate science. They are based on thousands of scientific reports, and they derive their credibility from the work of thousands of scientists and reviewers who get together and summarize all the very latest knowledge on climate science, global warming, and projections into the future. So those are the main reports, but yesterday a very special report was published.
Yes, you're probably aware there was a big report published yesterday by the IPCC. It was titled Global Warming of 1.5 degrees Celsius. You're probably aware of it. It was across the news, it was across social media. It was an enormous undertaking. It took 2 years. But why was it written? Well, for many years, limiting global warming to no more than 2 degrees was pretty much the standard target for policymakers. However, during the Bonn talks of 2015, a new UN report warned that 2-degree limit perhaps wasn't adequate enough to avoid some of the more severe impacts of climate change to some parts of the world. So after further expert dialogue, that formed the basis of the Paris Agreement in 2015, another report was embarked upon, and that was the report which was released yesterday. It was absolutely huge. It was an enormous undertaking. 91 authors from 40 countries, 133 contributing authors, 6,000 studies, 1,113 reviews, and 42,001 comments. Now, this report, in a nutshell, provides impacts of global warming at 1.5 degrees above pre-industrial levels, and we'll be talking more about what that means in a moment. And it relates to how we curb climate change, curb emissions of gases such as CO2. But also, and interestingly, it compares and it contrasts the impacts of a 1.5 degree world with the warming of a 2 degree world. So it's interesting because we see what the impacts would be and how much worse they would be if we just saw more warming of 0.5 of a degree, and there's some startling impacts actually. And the report divides very nicely into 2 sections. There's a full technical report and a shorter 34-page summary for policymakers, which Aidan and I have read. And there's some stark reading in that. So we'll be talking about that. We're talking about the impacts and what needs to be done. But first of all, I think it's time to introduce our guest.
That's right. Welcome to the Weather Studio, Professor Richard Betts. Now, if you could just tell us very briefly who you are and what you do.
So I'm a climate scientist here at the Met Office in the Hadley Centre, which is the climate research department, and also I'm a professor at the University of Exeter nearby, and I've been working in climate science for 25 years. I've been involved in several of the IPCC reports. In this particular report, I was an expert reviewer. I was also involved in the process of deciding whether the report could even go ahead, because when the Paris Agreement asked for the report, there was not so much research available, so we had to figure out whether we could do new research on the impacts at 1.5 degrees. As a leader of a major EU-funded international project called Helix, which looked at different levels of warming and its impacts, we decided, yes, we could do new work looking at 1.5 degrees to feed into this report.
And if you could just explain 1.5, what's the significance behind the number 1.5? Why are we looking at that number now?
Well, 1.5, it represents an increased ambition of reducing limiting global warming lower than the original target of 2 degrees. 2 degrees used to be regarded as the target, but it was realised that that couldn't guarantee avoiding some of the potentially critical impacts of climate change, such as, for example, taking the Greenland ice sheet past a point of no return of melting, which ultimately, over centuries or millennia, could lead to large sea level rise. You couldn't rule that out, even at 2 degrees. So countries with low-lying coastlines and small island states were concerned about that, so they wanted lower levels of warming, and that led to 1.5.
So these are tipping points, aren't they? They're points of no return. You get to a certain point and you get a runaway effect with certain aspects of the climate system. Is that right? And that's why we're looking at these specific numbers. It's trying to avoid getting to those tipping points.
Yes, and it's very difficult to put a hard number on it, but it's a matter of how much risk you want to take. And 2 degrees still had this risk of some of these tipping points, so they opted for a lower one. But then this report was commissioned to look at all the other differences between 1.5 and 2. So over and above any kind of potential tipping points, what are the more day-to-day impacts which will be avoided and reduced?
Now, when we talk about warming into the future, what are we comparing it to? There's a pre-industrial baseline, isn't there?
Yeah, so we typically compare things to the end of the 19th century, so like 1850 to 1900, because that's when the climate data and weather measurements around the world became extensive enough to let us know what the sort of global patterns of temperatures were. So that's the typical baseline.
So that's called pre-industrial.
For all intents and purposes, for a lot of the climate data, that's the baseline, yeah.
So how much have we warmed so far? I mean, there's a lot of numbers that fly around, and certainly there's the UK-based number as well as more global, but it does vary, doesn't it?
Yeah, so far the global average temperature has risen by approximately 1 degree Celsius relative to this pre-industrial baseline. But that's not the same everywhere. Some places have warmed slightly less, particularly around parts of the oceans. Some have warmed more, particularly in the Arctic, because you get melting of snow and ice, which exposes more of the dark ocean and land underneath it, which absorbs more sunlight and accelerates the warming.
Okay.
And this graph illustrates that, doesn't it? So along the bottom there, 1850 at the very far left, and then we've got present day, and you can see the warming accelerating in recent decades, and we're heading up towards the 1.5, aren't we? I think
we are. So you can see that the global temperature does fluctuate from year to year and even decade to decade. So the climate does change naturally. It varies from warmer to colder as time goes on, but you can definitely see an ongoing warming trend in the longer term. The spike at the very end here is from a recent El Nino event, a short-term warming event which happened for a few months and then went away. It'll happen again sooner or later. But the longer-term trend is definitely towards a warming.
So with the current rate of warming, where are we at? How much warming are we seeing, say, per decade? And if that was going to continue, when would we hit that 1.5 degrees Celsius?
So it seems that on average the world is warming at about 0.2 of a degree Celsius per decade. So if that continues, we'll be going past 1.5 degrees sometime between about 2030 and 2052 was the date put in the report that just came out.
Interestingly, in the news they talk about 12 years as the point where we hit that mark. But in fact, that's slightly ambiguous because there's an upper bound and a lower bound.
Yes,
why is that?
You can't predict the future perfectly. We're using computer models to do this. It's the same computer models we use for the weather forecast. We know they work on a day-to-day basis. They're based on fundamental atmospheric physics and they're tested in this time scale. But of course, if you're trying to predict things in the future, there's always uncertainties. You can't model everything absolutely perfectly. So we have a range of outcomes.
Exactly. A couple of questions coming through. Matthew Botel asks, because you can see here variability year to year, and you mentioned some of this is due to natural forcings. So Matthew asks, I and many other scientists agreed that this is nothing more than the Earth's natural cycle. So sun activity, volcanoes, that sort of thing, could that explain this unprecedented rise in temperature?
It doesn't explain the rise in temperatures that we're seeing in the last few decades. The Earth does get warmer and cooler naturally over the timescales of centuries and millennia due to changing the Earth's orbit, changing the sun's output and so on. But these things have all been taken into account. We know that we are increasing the concentration of certain gases in the atmosphere, greenhouse gases. CO2 is one of them, methane is another. It is perfectly well accepted that these greenhouse gases do warm the Earth. The Earth would be frozen if they weren't there, and no one seriously disputes that. We're also certain that we're increasing the concentration of those in the atmosphere by burning fossil fuels, by deforestation. So we know we're having this warming effect. We can calculate the relative warming effect of those things compared to other drivers of climate, such as the sun and volcanoes and so on. The sun doesn't explain the warming that we're seeing in recent decades. It's actually entering a cooling phase. Yeah, we're sure that the warming that we're seeing in recent decades is mostly man-made.
And in this report, it does actually fundamentally say it is down to human-induced warming. It says that black and white in this IPCC report.
So essentially, you've got the physics, which says that without greenhouse gases, the global average temperature would be about -18, wouldn't it? So if we didn't have them in the first place, then it would be a frozen Earth. Then you add 40% or something extra carbon dioxide into the atmosphere. Of course, you're increasing the greenhouse gases. There's going to be some warming.
Yeah.
But then is it important, as other climate scientists and yourself have looked at all these other natural things, could they explain, well, many of them are following a downward trend, so they should be causing a slight cooling effect. But these numbers, they don't sound that large on a human scale, do they? 150 years, almost a degree of warming. It doesn't sound that much, but when we go into and out of ice ages, for example, you get this kind of warming on the scale of thousands of years, not 150 years. So it's just the rate of warming, isn't it, that's the scary thing.
Let's just put that in perspective. If we were to talk about the next ice age, how many degrees, that's global mean temperature, would we have to dip into an ice age? What sort of...
It's similar kind of numbers to here, a couple of degrees or so.
The other way.
Yeah, the other way.
The other way.
Yeah.
Just another question that came in. The Arctic is warming faster than the equator, says RWTWM. And he raises an important point, or she raised an important point, that the warming that we've seen hasn't been evenly spaced across the globe, has it? So these maps show the globe, and you've got warmer colours going up here, up to 3 degrees for these purples. And it's the Arctic, isn't it? It's the far north of the globe that has seen the most rapid warming.
Yes, and also the interiors of the continents as well. So the oceans warm less fast, and the land warms faster.
Is that to do with feedback mechanisms?
It takes a long time to warm water. There's a thing called heat capacity.
Yeah.
So if you go swimming in the sea off the coast here, it's colder in June than September, because throughout the summer you have a longer time for the sea to warm up. So it's that kind of thing. It takes a while for the heat to increase the temperatures of the water.
This is interesting as well, because this is the annual average warming, and then below we have almost into annual warmings through a season of winter, winter, northern hemisphere summer. And you can see it's absolutely hugely significant. So the purples here is in excess of 3 degrees warming. So we're concerned about levels going above 1.5 degrees. It's already happening in some parts of the world, and particularly in the winter here across the Arctic. So it's happening already across some parts of the world. And those levels keep going up, don't they?
What would it look like if we just stopped emissions overnight? What would we see then in terms of the global warming trend? Would we still reach 1.5 degrees?
The IPCC report suggests that we probably wouldn't quite reach 1.5 degrees, that we would still see some ongoing warming. It takes a long time for the whole system to catch up with what's being put into it in terms of the greenhouse gases and so on. So there would be some warming still. There'd still be ongoing sea level rise. But it's thought that we probably wouldn't hit 1.5 if emissions were cut off now, which obviously is not going to happen.
No. And that's if we stopped emissions immediately. if we don't stop emissions, if we carry on as we're going, you've already suggested that we're likely to reach 1.5 somewhere between 2030 and 2050. And that's not long, is it? That's quite soon.
Yeah. So we'll be seeing this within a couple of decades, it seems, according to these projections based on the science.
That's interesting. This map, actually, this graph shows it very nicely. You can see that's the 1.5 line there. And these are various projections depending on how much we're curbing CO2 and other greenhouse gases.
Yes.
And then this is the zone here timeline between 2030 and 2050. And that's when we're likely to hit that level, depending on how much CO2 we do curb and reduce.
Yes.
It's quite stark, really, isn't it? When you read the report, you think, my goodness. So we both have read it, and the interesting thing, I think, when something which is one of the core messages that comes out, is that there is a significant difference between the impacts of 1.5 degrees of warming and 2 degrees of warming. So an incremental rise of 0.5 degrees, and a lot changes, and some of the impacts pretty much double or get so much worse than what they would be arithmetically. So can we talk about that comparison now and contrast between the 1.5 world and the 2 degree
We've
world?
got a little diagram here. It shows if you increase greenhouse gas emissions, aerosol emissions, land use changes, well, it impacts the weather. We've got changes in ocean currents, changes in the water cycle, warmer land and air, and so melting ice, rising sea levels, these things that we're all familiar with. But then those have knock-on impacts to human habitats, marine ecosystems, biodiversity, and so all of this is impacted by those increases in greenhouse gases that we've seen over the last 100 and 200 years. And yeah, there are big differences, as Claire was saying, between the 1.5 degree impacts and 2 degrees.
So let's take heat waves first of all. We've just had a quite significant heat wave across much of Europe as well as the UK. And the frequency of heat waves is likely to increase significantly with a 1.5 degree warmer world. What's the difference between the 1.5 and the 2 degree world? And there are significant differences, aren't there?
Yeah, so in terms of the maximum temperatures, they'd be actually going up at twice the rate of the global average temperature, it seems. So a 1.5 degree warming will lead to a 3 degree increase in terms of the maximum temperatures, and a 2 degree global warming will lead to a 4 degree increase in the maximum temperatures.
And in regards percentage of world population, there seems to be a real hike in that as well, from 14%, which was the 1.5, and the projection of up to a third of the world's population affected by extreme heat if we hit that 2 degree level.
Yes. So there's already people now in the hotter parts of the world will be experiencing high temperatures occasionally, but then they be kicking in more frequently at a 1.5 degree world and even more frequently at a 2 degree world.
And as Aidan says, that has a knock-on effect with nature as well as the human impacts as well, whether it be forest fires, it's the food security, whether it be invasive species coming in and really alarmingly disturbing the delicate ecosystems. But we're not just talking about heat here, we're talking about ice melt as well. And there's some quite startling numbers when we talk about how much ice would melt and in what part of the world, and how that would affect millions of people.
Yeah, so melting of ice is an obvious consequence of a warmer world. So the glaciers in most mountain regions are already being seen to melt and retreat. There's also the major ice sheets of Greenland and parts of Antarctica are starting to lose mass as well. Also, that puts water into the oceans, of course, which leads to sea level rise, and we're committed to an ongoing rise in sea level already. But also water expands as it warms, so that also adds to the rising sea levels.
So we're talking 10 centimetres between those incremental 1.5 to 2, a rise of more?
So if global warming was limited to 1.5, it would keep the rising sea level to 10 centimetres below the 2 degree rise. In both cases, sea level would continue to rise, but 10 centimetres less under a 1.5 degree world, and that has quite profound implications for coastal populations. It could mean that 10 million people less are impacted by sea level rise and coastal flooding and associated impacts at 1.5 degrees compared to 2 degrees.
The other thing I thought was very interesting with the report was they talk about some systems which could reverse if we reduce the emissions down to a point where the Earth didn't rise so high in terms of global temperature, and some Earth systems which would be irreversible. So we talk about the Greenland ice sheet, we also talk about coral reefs, and coral reefs almost seem doomed, however much warming we see now.
So coral reefs do seem to be one of the most sensitive ecosystems and are causing the greatest concern. So not only have they got to contend with warmer temperatures in the oceans, also they've got to contend with what's called ocean acidification. And so CO2 in the atmosphere increases, it lowers the pH in the ocean, so it goes from slightly alkaline more towards acidic. And the alkaline nature of the water is important for corals and for certain types of plankton, and they find it difficult to build their skeletons when this ocean acidification kicks in.
And in terms of fisheries in general, with warmer seas, and as you say, the alkalinity or the acidity of the seawater changing, it has a real knock-on effect on fisheries and the fishery industry. And certainly, you know, if you think about how many millions of tons of fish that are caught globally per year and that humans actually rely on for a source of food, that could decrease significantly, couldn't it, between that 1.5 and that 2 degree. I think that the number's around 1.5 million tons for the 1.5 and more than 3 million tons for greater than 2 degrees of warming. So you're doubling the problem there.
Mm-hmm. Yes. Yeah, I mean, there's these are the best estimates, of course. It's hard to sort of pin down the exact numbers, but these are the estimates that are being quoted in the report.
And there's a lot of numbers flying around in this report, and we're not going to talk about all the minutiae of that, but certainly, you know, every aspect of human life and natural life is touched by this and is affected significantly by this.
A few more questions coming in. Christopher Hesketh on Facebook says, is this not just a warm peak in an ice age dip? It all seems like a natural occurrence to me over wide climate trends. We've already talked about natural factors, haven't we? We are between ice ages if we weren't interfering with the climate system. But actually, it's thought that we might have warmed the world enough by human action to stave off the next ice age. I mean, that's a very difficult thing to really pin down, but it's theoretically possible that may have happened. And it may be that we peaked in terms of the warm dip following the last ice age thousands of years ago, and it takes thousands of years to enter an ice age, doesn't it? And it involves feedback systems from orbit changes in the Earth that lead to slightly more sea ice remaining in the Arctic during the summer, and that leads to more albedo and so on. It takes thousands of years for these things to happen. And if we just go and melt a lot of sea ice in the Arctic over the scale of 100 years or so, then that will just completely shut off the signal from orbital changes, won't it?
But these kind of the glacial cycles, they underline the fact that even small changes in the energy input and output of the Earth can lead to bigger changes in the Earth through these feedback processes, as you mentioned. So we are now adding a new driver of change in the climate system.
A few more questions have come in. A lot on how the UK might be affected. So Orville Blake asks, does global warming affect the jet stream in the UK? That's an ongoing area of research, isn't it?
It almost certainly does, but exactly how is incredibly difficult to predict because the atmosphere is so chaotic. We can forecast the position of the jet stream within a few days, and that's what we do here at the Met Office. But if you're looking longer term, it's really hard to say how these kind of things play out. And that's why it's really hard to say exactly what will happen in a particular place. We're confident the world's going to get warmer. We're confident that means rising sea levels in general. We're confident that means changing rainfall patterns in general around the world. In some cases, we know that some places will get wetter and some drier, but we can't always say exactly what will happen in any individual place because the atmosphere is so complex.
We're not saying that in 10 years' time we will never see snow in the UK, are we?
No,
because the atmosphere is so complex. We had a cold winter a few years ago. We had a couple of snowy winters, some snow in February last winter and at the beginning of March. So, of course, all of these things happen on the background of a warming world.
Exactly, yes.
I know, time is really ticking on here, but let's talk about curbing emissions. That's one of the most important things. This is necessary to do, and the framework that IPC has written is really a guideline for policymakers. And one particular thing, and I think this is almost pie in the sky when I look at the numbers here, is how much we have to curb CO2 emissions and other greenhouse gases. It's significant, isn't it?
Yes, the scale of the challenge, if these targets are going to be met, is just absolutely enormous. So this figure here is showing the changes needed in reduction in CO2 emissions overall by the 2030s and the 2050s. I think you've got this from the carbon brief, haven't you, I believe?
That's right.
So based on the results from the IPCC report, this has visualised that. So it's by 2030, CO2 emissions overall would have to reduce by between 40 and 60% approximately, but by 2050 they're going to have to reduce by around 100%, so go to zero basically.
By 2050,
yeah.
So we can't, if we want to keep global warming to below 1.5 or around that number, we just cannot have carbon dioxide emissions. And that involves not just the pollution that we emit, doesn't it? We're also included in the report was mention of carbon reduction and new technologies.
Yes, so because it's such a challenge to reduce emissions, because we rely on the production of energy and fossil fuels so much at the moment, and countries around the world don't want to just shut this down. A lot of countries want the same standard of living that the richer countries have got, obviously. So saying, no, we're just going to shut down our emissions, is you can't just say that. You've got to figure out ways to do this in ways which are not going to be harmful to the population of the Earth.
So it's got to be a sustainable plan. It's got to be fair to poorer countries. We've developed in our country, in the UK and across the Western world, we've developed by using CO2 emissions and nitrous oxide and methane and so on. So we need to be planning a fair way to reduce these emissions, don't we?
Yes.
And that was one of the key points of the
so the
report.
equity issue is really an important point. How this will be done as a global community with everyone looking after everyone else.
So huge changes on a rapid scale need to be made to emissions, to reducing levels in the atmosphere by maybe capturing that carbon dioxide and making changes to how we operate, how we use our land, vehicles we drive. All of that needs to be made immediately.
So, yes, there's no scope for delaying if these targets are going to be met. I mean, actually, we should have started this years ago if we were going to seriously meet these targets. Now it seems that it's technically possible. Whether it's actually feasible in the real world remains to be seen. So, yeah, huge changes. Maybe using land for new forests and so on. Using land for bioenergy and so on, but then the difficulties there is that going to compete with food production? There's all these kind of complex issues, so we need to be grappled with some urgency now.
It's a momentous task that needs to be done immediately. I think there was a quote in the newspapers that from a scientist involved in the report that just said, "Act now, idiots." Right?
That was actually Greenpeace putting words in the mouth of scientists, to be honest. So the scientists did not say that.
No scientist said that. No scientist would be that crude.
No.
But you, as a scientist, an expert in this field and involved in these reports, do you see signs of optimism? Can we end on a positive note?
Yeah, the fact this report has come out and it was actually asked for by the policymakers shows that this issue is being taken seriously, and it has received a lot of attention. Most people accept the science. The debate now is exactly how we deal with the problem. I think we accept that there is a problem. How we deal with it is now the contentious issue. But I think I have faith in human ingenuity. I think we will find a way through somewhere or another. I think it'll be a combination of reducing our impact on the climate, but also learning to live with some of the changes that are already locked in. Some are already unavoidable, so we are going to have to adapt to a certain extent. So a mixture of these is how we will adapt and get through this.
Cause for optimism, but certainly a big wake-up call for all of us. Yeah.
Richard, thank you very much. A very sensible voice, actually.
Yeah.
It's really interesting. And as a climate scientist, your work just carries on, doesn't it?
Yes, it does, yes.
Certainly. OK, thank you very much. I hope you've enjoyed this show. It's been a bit different from normally, because we normally talk about weather forecasting and what's happening. Indian summer, that's all I'm going to say to end this 1 o'clock Weather Studio Live. And yes, enjoy the warm sunshine.
Thank you for
tomorrow.
sending in your questions. We couldn't get to all of them, of course. We may be able to answer some next week, but we will be back this time next week with another Weather Studio Live. Look forward to seeing you then.